Hello, good morning, Mike.
Good morning, Jack, or good almost afternoon. We'll see.
Good
It's it's
almost, yeah.
uh it's July 3rd, long weekend ahead, I guess. And
Yeah.
great to catch up because I can't tell you how much is happening. It's a lot. How about you? But I'm actually more tell me because I am again you're writing more now for LinkedIn and I want to know if you can share some of that.
Yeah, so there's a few things that I'm implementing right now, and I thought that's going to be maybe interesting for people to see on Medium or LinkedIn about the agentic architectures. So yeah, I think as you know, AI is a little bit underhyped, in my opinion. Uh,
I think it's still not quite. Yeah. Yeah, no, actually, I mean, but I'm agreeing. I actually think people get the wrong mental model, if I can use that word, of what it is, right? Because I do hear a lot about business, and I don't mean to overstep your
Mm,
point, but I just mean
mm,
I hear a lot about businesses are like, well, we're gonna fire a bunch of people and replace you with AI. And of course, as we both know, I don't think any businesses even vaguely understand how they run at all. So how
mm,
you replace somebody that you don't know what they do was always my big
mm,
problem, right?
mm,
Like, sure, you can just get rid of people. That never seemed to not work. But to
mm.
say that something you do is replaceable by AI, I think is very contentious for me because I don't think that's true. But please, what's
Yeah,
your point?
and that's a little bit of a weak point, that I have, because you might be true that the businesses really may not know kind of like the operational kind of details, and there is the old saying that you cannot automate a process that you can understand, right? So if you don't have a nice diagram, right, or something, then really it's a problem. But on the other hand, right, with the enthusiasm, kind of natural enthusiasm towards AI with me, there's mechanisms that if, let's say, we are wrong, right, let's say there is a way to describe what we are doing in a pretty good detail, then there is something that we can do that is quite powerful. And maybe if I can share my screen
Yeah.
for just this for a second. Um, then in the can you see my diagram?
Um, I'm getting
Yes.
some weird bandwidth problems. Are you?
I'm not sure.
Yeah, I'm
Yeah,
I'm
so
super blurry. Weird.
okay, well, I'm gonna try to
May-
maybe I will try to zoom
Maybe
in.
we're out of phase or something. I don't know. It looks like a bunch of Chinese characters.
Oh, okay. So let me close, and let me reshare one more time. So maybe that's gonna
I
help.
mean, I'm seeing this as being fine. Sorry. Like this looks normal, you and me. Oh no, you're perfect.
Oh,
That's better. Okay.
oh,
Yeah.
okay. All right. Yeah. So what I'm working on is something that is called an MCP framework.
Yeah.
MCP
Yeah.
stands for
Hey, I know. Come on. I was the MCP train a while back, remember? Anyway, keep going.
yeah. So model context protocol, and
Yes.
essentially what this thing does is that if there's this MCP server that is aware of the tools that exist. So this is the weak spot. Like okay, you might be right that we really cannot describe the tools, right? We really don't know what the tools are supposed to be, but let's say maybe we have a use case that is a pretty well defined one, and we can really kind of have a very good clarity about what those tools are supposed to be, right? So, like for example, maybe some sort of a machine learning question where you would like to run some sort of a classification, like, hey, maybe you send an email and you would like to know if the email is kind of relevant to the topic or not relevant, right? So maybe a binary classification. So maybe tool number one is supposed to run the binary classification problem, and then maybe tool number two is going to visualize the outcome of the classification. Maybe we'll make a diagram or a graph, or maybe just kind of say, hey, based on the outcome from the machine learning system, right? We will consider that here's your, here's the answer, right? So, or we can have like an n number of tools, obviously, right? So if we can describe well what the tool 1 is supposed to be doing, and then what tool 2 is supposed to be doing, then this is a pretty powerful environment, because the question that is going to come into the MCP server is going to be analyzed by a large language model to recognize the intent, right? And then based on that and the awareness of what the tools can do, the AI is going to pick, okay, so I'm going to start with tool number 1. I'm going to run through tool number 1 for you and kind of get something going. Now, even more powerful architecture would be that those tools are not hard-coded. They are generative in nature as well. So maybe my original question could be, hey, please tell me if my email is relevant or not. So it would be a binary classification. But let's say, I feel good, I had my morning coffee, and I would like to have maybe classification into 3 categories. Maybe, hey, tell me if my email is great. Tell me if my email is so-and-so. Or maybe tell me if my email can be improved in a number of ways. So the machine learning question kind of changes, and maybe that is something that can be now handled through a generative process, where tool number 1 is not just running the machine learning algorithm that is hard-coded, but it's going to generate it based on the intent that the MCP server received, right? So now, okay, I know that tool number 1 is the way to go. It's going to generate custom code, maybe Python, something from Python ML libraries, and it's going to kind of get ready, and then it's going to execute that, dynamic tool, and then it's going to send the results to the, back to the MCP server. So if we can pull that off, and I think I'm kind of quite successful in this, then this is kind of this is a reason to be enthusiastic.
So I think I'm following pretty well. I do, there's a couple of actor questions I always have, right? Because, we have this idea of an LLM, which is nebulous at best, right? I mean, there's a lot of them. And each of these models, I've lately been pitting them against each other. It's sort of like having a bunch of eager grad students, like, hey, you tackle this, you do that kind of feeling, and see where they start to triangulate. But they're all very different. And then I also have a problem with the idea of me as an actor, right? Because right now, like, people themselves don't really have sort of a consistent token, like, this is the kind of questions that Michael has versus the kind of questions Jack has. I'm just wondering, the architectures are still not formulated around that problem yet, right? I mean, right, this is looking pretty linear is what I mean, even though it's linear, right?
Yeah, it's a linear process only in the diagram, right? But it does not mean that I am unable to rerun the process if let's say, because what happens to the outcome of the process is kind of let's not forget that we are in an agentic framework here, that the agent will have an insight into what the output is, whether that output is sufficiently correlated based on whatever the rubric we want, but whether the outcome is sufficiently relevant to the question or to the intent that was created. So if it is not, then we are going back to the MCP server kind of initial state, where it's going to kind of maybe try to rework its formulation of the intent, maybe change something in terms of the problem description through the internal agentic introspection. So this this could be more of a kind of like a recursive loop than a linear
That's where I'm
process.
going, because I think recursive loops are the best, and that's the new model for everything for me, is a recursive loop, because it's so difficult to program in any other way.
Yeah.
Right. But
Yeah.
this kind of, it kind of settles on that, because actually it'll use the recursive to tune. Although I do have a question. When we talk about agentic, does it kind of mean, like, again, more tokens, a bigger token window? Like, what does that even mean? Because I always think as humans, how often do we switch context? Like every 5 minutes, right? You know,
Exactly.
whereas, you know, we don't mind that. I basically also just went out and I watched this new movie 28 years later. And I don't know if you remember this earlier movie, but one of its staples is that its camera is always moving in really jarring ways, right? Like you're always constantly like bombarded with this stuff. And when I'm watching it, I'm kind of like, wow, it's weird that we don't find this. I mean, we find it exciting, right? That it doesn't make any sense spatially or time-wise, but we don't have any problem with it, right? And that's why I wonder about Agentic. Like, can it understand how distracted we are? Sorry, is this too weird of a question? I don't mean it to derail.
Well, your earlier point for me is easier to answer, right? Like,
Okay, please. I love recursion.
Does it mean more token counts? Absolutely, right? Does it mean more calls to the LLM to kind of like, hey, you know, let's kind of recognize the intent. Let's kind of like create some sort of a task summary. Let's evaluate what the outcome is, right? And then this tool here has to make possibly multiple calls to the LLM to kind of generate the code. So yeah, so all the above. But yeah, but the question now, how, you know, I mean, here's the user, right? And the user is busy and doesn't want to kind of have a cognitive load, doesn't want to know what's going on here, right? Like on you know, in this kind of framework. Yeah, so you are absolutely right for the tool, but that is something that unfortunately maybe with multimodal kind of AI.
And I'm saying it's fabulous for experimentation and prototyping. I'm just saying it's also a learning model, right? Like, which is how much do you need? How much becomes, well, I think of it like like our education model, right? We grew up, or at least I did, you know, you go from English class to gym and then to what, like you were context switching all the time, right? And somehow we were never thinking necessarily that was bad for people. But the minute I got into art high school, we had 3-hour classes where you did one thing for 3 hours and it permanently rewired my brain, right? Yeah. Because I just, you know, there's only so much you can do in 45 minutes, of which 15 is getting ready to do something. You know what I mean? It's a weird system, but I like this idea also from learning systems, right? Like, why would learning systems not be able to be persistent rather than being, well, like the internet is now? You just want to switch to something else constantly because you want more. Whereas this could say, no, stick with it. You can do it, which I can describe in a minute. But does that make sense? Just as
yeah,
observation?
Absolutely, yeah. So yeah, absolutely. So to your point on learning, right? Like, what can we learn from this process, right? And that kind of goes to your initial question, right? Can an organization really kind of describe what it's doing, or you know, is there a knowledge transfer? You know,
well, or do we keep any knowledge at all? Which I'm kind of saying right now that we don't. I don't think we have institutional knowledge.
Exactly, right. So what I'm trying to do, so the key to that is obviously knowledge, right? So what I'm doing here is I'm formulating the knowledge in chunks that the AI is very efficient with and kind of likes doing. So what you're looking at here is several chunks or several kind of fragments that kind of deal with the institutional knowledge, right? So I can have basically database descriptions. They are not very, they probably exist, but in many organizations they are not there. but I can use AI to do that, right? to build those. So so database metadata that describes what is the content of the table, what are the samples, right? What are the new unique values, right? So how the AI can be aware of what's sitting in the databases. That is kind of the first knowledge fragments, right? And we kind of divided into like activity hub, basically kind of like a collection of tables,
Sure,
knowledge
sure, sure.
fragments.
Taxonomy.
Right?
Come on, love
Yeah,
it.
exactly.
I'm Mr.
Yeah.
Taxonomy. Sure.
Yeah, so some of them might be VHLFs, very large knowledge fragments, right? Like, for example, that there might be a column that will have some really important unique values in it, but there's going to be thousands of them, right? So the AI has to be aware because, well, what if I have a question about a particular maybe widget, right, or particular SKU, right, that has a very weird name, right? AI has to know what that weird name is if I need to have a conversation about some sort of a product management or whatever, right? So this is important for the AI to be aware of. Now,
Well, and
there
don't
is
forget question 13 on your evals, right?
exactly.
There is
Yeah.
only one question. Would you
Yeah,
recommend someone else take this class? Is the only question they looked at.
that
So
that
remember, there's
matters. Yeah.
also it's going to be hacky. The problem is the database, has
Yeah.
everything in it, but they only look at one thing and they won't tell you what that thing is. Sorry.
Yeah. Exactly. Right. So so let's say if the databases exist in our context, yeah, they have to be very well described. Now, the next thing that needs to be present is that there needs to be the agents need to know what to do, right? So that's kind of where the tool descriptions come into, right? Like if I have some sort of a machine learning procedure, or if I have some sort of a statistical analysis, or maybe even an email authoring tool, right? Those things have to be described, and I call them agentic tools, knowledge fragments, right? Sometimes they need to be searchable in a very, very efficient way because there's a lot of it. So they need to be converted into an embedding or EKFs, right? And then maybe some of that stuff needs to be maybe repurposed. So let's say I have some sort of maybe PDFs that are not going to be working too well with AI systems. Maybe those PDFs needs to be converted into something, like MRKFs or machine readable representation through, let's say, tools like unstructured.io or something like that. So there is that. Then there is another thing that, let's say, if humans are willing to share, or if human knowledge exists, then there is also these knowledge fragments. Um, so there is the maybe textual representation, or maybe knowledge graph representation that is very, very useful for our purposes, because you can show an expert the graph, right, and say, hey, look at those bubbles and those arrows, do they make sense? And that is a very good way to have a conversation with an expert, right? And then the learning process. Right. So let's say we kind of start running this thing, and we can kind of now start looking at, what the AI thinks about, the whole thing, because let's not forget that we are in the agentic environment, so we can have an introspection. So we can start generating feedback on the descriptions and all the other knowledge fragments, and we can call it, knowledge fragments, AI generated knowledge fragments, or knowledge graphs, or whatever. So then, right.
Okay.
So then just to kind of finish the thought, those now can be distributed. Those formats can now be distributed into knowledge bundles. So they can be grouped and associated with, let's say, whatever the tasks we are trying to solve in that consistent representation, which actually is a very useful thing to have. So that has a good chance of working in my kind of prototypes that I'm working on. So yeah, I guess, yeah, please
Oh
ask
yeah,
questions.
yeah. No, I'm very excited. I mean, I'm still trying to, and I would love to know, and let's just revisit, because again, the fun thing of this is probably let's just assume that the cost of experimentation is lower than normal. for this kind of ambition, right? Because I'm going to give you my own example, which you're going to laugh at me, but I'll do it anyway. But one of the things I've really always kind of wondered from MCP is architecturally whether there's sort of a layer of meta knowledge, right? Like the thing is that's what I don't necessarily like about, you're not retraining the models, right? Models are trained and you just interact with them, right? Now it can keep some sort of token or whatever, some sort of vector about you, which it does now, so it sort of knows, again, me, even though in itself, I'm starting to see it's a little multimodal, like it'll act a certain way in text and now it acts a different way in voice, which bugs me a lot, actually. At least this is GPT. I don't use voice with anything else, but GPT at voice tries to be like a friend now and very brief, whereas it'll be much more verbose in text. And that's interesting, right? Or does that make sense? I'm just saying, that we're not talking about retraining a model, right? We're saying MCP can sort of keep these meta layers clearer so that we can diagnose something. Well, and I'm thinking, you might be working with a lawyer who's got 50 years of experience or whatever, right? Or a paralegal. Now, the point is they should have different mental models and need different things from the system, but it just needs a vector to know where to go. So I've convinced my GPT that I'm an expert in physics now. And if you want, I can tell you my story, but maybe I need to share my screen.
Yeah.
But just back to that idea, right? Like we aren't what we propose to be. When I'm in English class, I propose that I'm somebody interested in English. Or I'm not actually a basketball player on break from basketball. You see what I mean? That's the way humans really are. And I'm just curious, like I think those are really fun problems now that we can actually try to build these systems that can understand that kind of complexity. I mean, for UXer like me, I think it's great, and does that make any sense? I guess.
Totally. Yeah. So I think that the user profile, right? Like, hey, I'm a physicist or whatever, right? There's going to be more and more tools that will kind of implicitly do it for you. Exactly like the knowledge fragments that I was showing. Most of those things are implicit, right? You don't have to interact with them explicitly because you are busy and you don't want to know how AI is kind of munching on the knowledge, right? So there might be definitely, but those frameworks need to exist, right? And those frameworks can be very heterogeneous. Like one of the best metadata that I know of is actually code. Computer code like C++, Python, SQL, or whatever. It is such a crisp and very direct.
It's linear. Come on, you got linearity. That's what I'm going to say in a minute, right?
More than that. It's unequivocal, right? It's really,
exactly.
There is really not an easy. It's not easy to misinterpret it. Right, and that's kind of what is kind of great about artificial languages like programming language. That they are not in the Gödel abyss, right? They don't have infinite number of senses associated.
Right, no infinities. You don't need infinities.
Yeah, exactly. Yes.
Well, and that's the problem with the universe, right? Is that I'm trying to come up with this thing which I've been working on, I guess, for a while, but now I'm starting to get to the point where I want to publish it. So I had an interesting experience, I guess, this week. So let's just say that in my mind, my propositions are well formed, and unfortunately, they're one of those things where it's absolutely like non-trivial, right? Like this is one of these crazy ass, theories, or whatever. But I'm very committed to it, and I really enjoy it. So let's just imagine I was a grad student in physics. My problem is that one thing I would have to do is I'd have to learn mathematics and I'd have to learn geometry, right? So what is happening with my theory is I realize it's very anti-geometry. Basically, I'm kind of saying that geometry is not correct, right? It is not a way to model the universe. Now,
because we are so used to the Euclidean model, right?
Well, and, that's what I mean. form the universe based on this Euclidean model. And even Einstein, who really could figure this out, had to stick to this model because it's like being an artist. I said, hey, artists, we just reform the universe. We're not embodying it. We're making it better. We're making it prettier. And all the buildings that we build and everything we make is based on geometry, right? Because it's easier to build that way, right? You don't build recursive structures, right? That's like your pet dog. That's a recursive structure. You just feed the dog or whatever. Take it for a walk or I try to take it for a walk, right? At least my dog. But you see what I mean is we aren't naturally attuned to it, so we want the universe to be Euclidean. So my theory is, first of all, saying no, forget all that, but then I can't forget all the things that you've discovered which happen to be true. So I will just tell you, I had a very interesting time because that was my thing, is like I got a pretty good idea of what I want to do, but I don't know any way to prove it, and I'm not in a physics class. So the thing is that if I was in physics, I would have all this beaten out of me by now, as our education system is wont to do, right? Like it gives you the tools. Sorry, I'm gonna indirectly talk the word tools, but you see, you can read what you want into this. It gives us the tools to do this job in a particular way, just like you said with code. So here's my problem. I don't code anymore, right? I don't have any reason to, but I have a reason to need code to work, right? I have a problem I want code to solve. But
I think there might be something weird that's going to happen with code, because chances are that because it's such a powerful tool, right, for representing whatever, maybe we will go back to something like that, like the Lego. You remember the Lego programming language, or maybe
I do. Oh yeah, Smalltalk. Yeah. I mean, come on. I mean, I've been around in this forever. In fact, I am remembering my Unix commands now because I have to use it so much.
Yeah,
but I grew up on Unix.
Yeah, and maybe that's going to be something that people will adopt because they will realize that talking, to a chat GPT using, English or Chinese or Japanese is such a process, requires a little bit of a kind of knack to it, and I think that there's going to be maybe other artificial languages that will emerge, like kind of like a shorthand record, when we text, maybe something like that will be kind of like, very, very useful for AIs.
Well, you bring up a good point. I think it's that, I mean, I certainly 100% have learned how to articulate things better because of GPT, because it's of practice. Yeah. Let's just call it practice. And I just wrote this piece about safe spaces, and I'm bringing up the idea. Have you ever heard of Building 20 at MIT?
No. Okay,
so my whole point about spaces is that just like our geometric universe, people want to design, just like they want to design some sort of useful thing, right? And they want it to be empirically designed, meaning it's on purpose. And the point of my piece is actually that no, these places don't work for people. We don't work that way. And so what happened is that during the war, they built this building on the MIT campus, kind of a shitty building where they studied some radioactive stuff or whatever they did.
Oh yeah, you mentioned that. Yeah.
Okay, anyway. So the point being is that you just threw a bunch of people in here that had no money and really no one cared about them. And that generated, in at least historically, the most creative place on earth, right? Like all these people. And what I'm trying to say, it really wasn't the people, it was the environment. It was the environment where you could fail quickly, you could get quick feedback, you would run into things that weren't in your field, right? That's, I think, a huge one coming from Scrum, which is a team can solve anything if they all have different talents, right? And if you get 5 programmers in a room, nothing will ever occur. You see what I mean? Like, that's the point. It becomes, you can't just throw more resources on a problem. And I do find all this getting rid of people to be the opposite, which is every system I've been in works on chewing gum, basically. Just hacks learned from experience that you have to put into these systems. I worked for Salesforce. Remember, I had to hack Salesforce, which is a wonderful, really well-designed system, but everybody wanted to hack it. to model the model because they didn't know how it worked. They don't know how payroll was processed. Do you see what I mean? Like so many fundamentals of how business works, if it's been around long enough, nobody knows. And that's why we were talking, you have these incredible legacy people who really just keep this one machine running. And I knew that machine in Bank of America. It was in my office. It kept the bank running. It's insane. I'm really not joking. Like this one computer ran most of this stuff because somebody at one point had this problem and they got to spend maybe a year on it, you know, and nobody really cared until the problem was solved. And they're like, well, whoa, great. Great, that problem solved, which is like me. I don't want to do any of the work, right? I just want the problem to be solved or to learn something, which is even better. Like, oh yeah, we put all of our money in Bitcoin. What could be wrong with that? You know what I mean? It's like, no, you want some system that you can have some sort of learning cycle to it, which is where I think I'm at. So I'll just show you for laughs if you're following and not sick of this already. But here, so here's number one.
Yeah, I think the story resonates quite a bit. You know, I also worked with for a company that had like one server that ran all the clients, 700 clients. If that server crashed, you know, there is no company, right? And
right,
you know,
and they don't even know that is the point.
Yeah, and then me kind of being kind of like naive, right? Kind of coming with an idea. Hey, let's buy a second server and create a backup. And then the answer from upstairs, you know, but this server, you know, has like 200 gigabytes of RAM. It would be too expensive to actually have a second one. Yeah. So yeah.
I
know
think it's the hubris, right, of design that, you know, somehow Sam Altman has all the answers. That's what I keep thinking. Like, you don't even know how your company runs, to be quite honest. Obviously, since your three main people just went over to, you know, get their Learjets from Zuckerberg, right? And it's that thing of like, yeah, you don't, why would you know? Again, it's not part of your job. You're not supposed to know, but what I mean is I think the institutional knowledge being nowhere, you know what I mean? It really is nowhere. I've worked for as biggest companies ever on their knowledge and nobody knows how it works because everything's anecdotal. It's all done through necessity, like everything should be. You know, you can't just sit there and learn geometry because you want to. You learn it because you're forced to.
Well, yeah. I mean,
no, believe me, I made straight A's in geometry. I loved all of it, but I never got to use it for anything. You see what I mean? The minute you left class, it wasn't as if, you know, I started to deconstruct the structure of flowers in my whatever, you know what I mean? Like you have to have a utility, and that's why it's fun for me, because I actually can just invent the math. Then I can just find out that somebody else invented the math, which makes my life easier. You see what I mean? Like, I know that there has to be this math, but I'm not smart enough to invent it. I happen to know there needs to be Planck's constant, but I don't have to understand how it was ever derived. I just need to know what it's for. Does that make sense? So it's fun. It's a lot of fun because then you get to uncover the whole world of physics without going to physics school, except if you want to publish, which is what I want to do. And so now I'm even in a weirder position. So here's the fun thing, which I think you will find this amusing. So I'm postulating that there is a field of time that exists and all the universe is based on it. So huge change in everything to do with everything, right? But by the way, don't let me forget analog computing. By the way, we need to do a startup. Okay, so huge field of all matter is based on it, which is another thing, but I need to prove it. So the problem is that in this frame, we are already resonant with it, and all our measurements are based that we're all resonating in the same field, right? Makes sense, right? You can't see the field you're in because you're in it, and everything's tuned to it. So I kept thinking, well, how would I do this? And then I kept thinking, well, I could take GPS, okay, and I could take the satellite data, uncorrected satellite data. I can just say, here's a clock running over here and a clock running over here, and it's sampled every 30 seconds. And so I asked GPT, and this is the perfect thing about GPT, by the way. Like this is the thing, if you really wanted to do this, it would take you years because everything is not easy, right? So guess what? GPS, how do I get at it? I write a letter to the GPS people. I'm like, where do I find this kind of data? I want uncorrected GPS data. And they're really nice. They wrote me back and said, it's over here. And then I go in. Did you know that starting in 1980, there was a folder labeled 1? And now all of the weeks, and it's in weeks, are numbered that way, right? So I'm here at week, I don't know, whatever, 600 and something. And in that is a ton of files, like literally hundreds of files, and they all have weird names and stuff like this. So thank you, GPT. I'm like, which ones do I want? And so after a little bit of help, it helps me narrow it down to the JPL ones, and it helps me narrow it down to these particular clock files, which I then FTP in and download, which is fun. Remember good old, it's all just sitting there, right? So I have now, for my experiment, here is about 2 million rows representing, I guess, what would that be? Like 7 weeks, because I'm figuring like if any patterns there, I don't, whatever. So far, so good. To me, that's already a PhD. Just that I kind of figured out like how to get this stuff and what I want to do with it. So let me just share with you, because I learned a new tool. Speaking of tools, which you will now laugh at me, allow. Because you know all this stuff. Come on, here we go. Are you seeing this?
Yes.
So in this weird thing, I've now learned why Jupyter notebooks are really cool. Oh, are you a Jupyter notebook fan? No?
Oh, yeah.
Oh,
Use
okay.
it quite a
Well,
bit.
it just makes it a lot clearer and cleaner, right? So I'm basically, I do not know Python, but I'm just going back and forth, right? Here's what I wanted to do. So as I said, I've got 12 million rows of data. And by the way, I had to create a database, which is also really hard. You know what I mean? Like this stuff is just like a big weird file, so I have to actually concatenate it and do all that other fun stuff. So are you impressed yet? Like this is all like heavy duty hard work if you didn't know how to do it. And would also, you'd have to take classes or whatever, go to Stack Overflow. But fortunately, this super awesome transformer machine can do most of it. It doesn't make it, it's not perfect, obviously, but it will, if you know what you want to do, it'll help take away some of this flow problem, right? Especially when it comes down to all the crazy stuff. So anyway, so now I need to just say, hey, I need to take, God, what is it? Hilbert space. I need to understand Fourier transforms, and I'm looking for Shannon information in it, right? So I know what these things do. I just don't know how to do them. And so here I am figuring out how to do these drift matrix conversions. Then I can start to correlate it, which is the whole point. Is I really have no idea what to look for, but I know what I want it to do. You see what I mean? It's like this feeling of like why you would get a degree, but the problem is the degree would throw you off. Because you'd learn geometry, but you wouldn't learn what geometry is for. Am I making my my idea clear?
Yeah, absolutely. Yeah.
And so just to let you know, so far so good that I am getting really good ideas that there is two different things are seeing phase problems, which was my whole point. Like they should be out of phase with the time that we understand, and that two things in opposite lands should also be out of phase. Now, if anyone knew what they were doing, they could probably easily tell me that I'm an idiot, but that's still better than nothing. You know what I mean? Like I'm still getting somewhere in seeing that instead of this being a we live in space where nothing affects anything. Instead, no, we live in a very, I hope, interesting field that explains, well, pretty much a lot of stuff, right? So what's great is that, it has also helped me to make interpretations, and now I'm sort of still trying to use this to, to be able to articulate this stuff. And as I said, if it was a PhD, I could just imagine, again, this would take years, and then you'd need lunch, and then you'd need to go on vacation. And do you see what I mean? Like, it changes the format of, I think, the kind of problems maybe we can experiment with, like you're doing. I mean, I'm just putting it in the fact that you can now experiment with things that you could never do on your own. You need, and then imagine if you had more than one person. So what I figure is, like, these are my eager grad students, right? Like, they'll go do the work, and all I need to do is direct them. But then I need to understand what they're saying, and I need to obviously give them feedback, right? Like, it's still my stuff, but it's a very fun place to be. Now, again, I'm in the midst. What do you think? I don't know. Seems like a fun thing.
Oh, this is super fun, right? I mean, you are kind of touching on so many, relativistic effects. You are kind of, measuring, time delays between, objects that are, very far away. This is so cool, and you have a data set, right? And so you are absolutely right. Chances are that there is PhD dissertation research in that, where you can maybe kind of come up with kind of new optimization algorithm, and all of that, with tools that you can create, through the programming, AI, and with knowledge that you can be pointed to by an expert AI, right? So all those, you are turbocharging your intelligence, right? So this is AI intelligence amplifier, that works for you. Yeah.
Well, but I guess what I'm trying to extrapolate, and I could be wrong, is anybody could do this. And that's what I mean, is rather than firing people, we should get them in the job of teaching us what they do. Right?
Yeah,
and then
course,
to
yeah,
give them more time to take time off and enjoy their lives, but also to be more effective in guiding when it doesn't go right, because we live in a chaotic universe, is what I'm trying to point out. Like, everything should be changing all the time, and it is unpredictable and not like a clock. And back to, so here's my pitch on because I believe anything bound within frequency domains has natural behavior to either reinforce or to be nulled by those frequency domains, right? So you get this natural behavior. I'm really keen on analog computing now, because can you imagine now because it's already bound by wave functions, right? It does not have the clock. It doesn't have this sort of empirical speed that is necessary for all the magic that we like to do, but it's probably really good at other stuff. Like, again, things that are more, let's call human, right? Like any kind of, well, and I don't think that it would be bad at AI is the other thing, right? Because it in itself is sort of all about wave functions, in a way, right? Like, it's all fairly plottable in terms of weight. I don't know, just a thought the first thing I ever did in 5th grade was that my science project was about computers, and I built an analog and a digital computer. And I did win first place. I did not win the regional of science fair, but I was pretty happy to go to the regionals, after winning whatever, because who had ever even heard of a computer at that point? It's whatever. It was a long time ago. But analog computers were silly to me, right? Digital computers were the way. But now I'm starting to say, like, well, no, if you start to think, well, no, this other stuff is really powerful. We just didn't know how to model it.
Yeah. There's definitely something to it. I mean, maybe the front end will be the analog version, but at the back end, there's always going to be the GPUs that are running those vectors, and kind of creating those activations, propagating them through the neural networks. There's so many things to look at. I mean, last year I was at a conference, and there was a NASA engineer, and he was showing how they design now, like like attachment points to some. So let's say you want to attach a camera to a spaceship or a satellite or whatever, right? So you can kind of like have like a T, right? And then there's something here, right? But then if they feed this into a AI, they kind of create this kind of like a bone structure that is 10 times lighter and much stronger.
Right,
So,
exactly. Yeah.
But so they said, so NASA wants to create like a 10x engineer now with the AI. But maybe what's going to happen is that they're going to let go 10 times more people and just going to keep 10%, and something. So I don't know. I mean, if they had really that vision that you are describing, like, hey, look, there's so much knowledge, let's empower people so that they are like 10x or 100x better programmers or whatever.
Yeah.
But that's not happening. They are letting go of people, that could be so much productive.
Well, my next chapter is about cheating, right? So this is the point. Like, you can always cheat, and there is a lot of reason to cheat. And both you and I are pretty confident in that cheating is not our, you know what I mean? Like, the other day I was just thinking how incredibly lazy I am that I don't want to learn physics. But perhaps it's a moot point. If you're looking at this, it's like, well, why would you? I mean, you learn physics by having a theory, and it kind of puts me back into, kind of my respect for Einstein, which is all he did was really sit around, right? And he had a few books and he had some tools. And he sat around for an awful, he had a long time, and he just thought about stuff, right? Like, and somehow managed where, and that's his talent. And that doesn't mean everyone wants to do that. And I don't want everybody to do that either. And I do think there's a feeling of like, well, if you get people who are really like, what do they call them? Senior devs, I was like, well, you're only senior because you have weeded out most of the noise. But we now have a tool that's literally a harmony, it's a harmony machine, right? Like, that's all it understands is harmonies.
Yeah, I agree. I mean, the definition of cheating is actually, getting more and more difficult, right? Like, what does it mean? I mean, your exploration with a large language model, is it cheating? Because you are not a physicist, I am not a physicist, right? But we are kind of now trying to understand stuff and maybe put together something that is interesting and maybe contributes something. So I don't know.
Well, certainly my physicist friend is not impressed. And my fun thing now is to have my crazy theories. I'll just go back and forth to another model and say, tell me all the terrible things wrong with this theory, which is usually really good. Like, you just pit them against each other. And what's fun about it, I think, is that if I was in school, and this was a big part of this article pitch for going and reading the article, any readers out there, it's called Safe Spaces, Dangerous Thoughts, which is the idea that, if we are truly unjudged, sometimes that's when you can find your true talents, right? Like, it's when I would go to my physics professor, if he would even talk to me, right, and say, hey, I've got this theory about da 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 da, and he would immediately be, because he's a noise reducing machine, that's his point, is he would, and that's exactly what my physics friend did. No interest whatsoever in any of this. I pitched it every which way, right? And no, it's just, again, that's not the realm. And so now are we going to go into our businesses and say, okay, the people that aren't domain experts, they can all go. And that's this problem that I've been seeing, and I wrote about with I read about the FANG people. They're like, hey, we usually get in people who want to be interns, right? And I remember interns, right? We used to sit them over there. And it's this thing of like, oh yeah, you can sit over there, and if we need you, we'll let you know, right? Well, he said the problem is that now with GPT, we used to have all these screener questions for programmers, right? And everybody wants to get in. Now all that's flat. Everybody gets all the questions right, and we have no idea what to do now, because that used to be our noise machine, right? Like, hey, everybody, these were these things that were hard. And you said, well, we concocted this tests that had to do with like, again, domain knowledge and kind of like you're dealing with, right? Like here's these very complex spaces that even you with all your resources can only begin to shine a light on, which is great stuff, right? Because there's no empirically, like there's no manual that says how this is how it's done, pretty much. So anyway, he said, well, we had these big problems in whatever that's called, domain, whatever. He said, I would hate to take this test, and I've worked here for 15 years. Like I wouldn't be able to do it, and this is for an intern.
Yeah.
So this is the weird thing, which is that is the benefit of just being in a place now the only real criteria for employment, since I don't know how this travels in other disciplines, right? I just probably know programming, right? Because where are the super junior programmers? What are they good for, right? Where's the grunt work, right? Where's the cleanup? Where's hey, what does this server do? Oh, that server, oh, it runs everything. Wait, but see what I mean? Like there's this room and I think need for those people. In a weird way, I think they're more valuable.
Yeah.
But if you get rid of them, I think you're just going to kind of sign your own. I think it's not going to be good. That's all. Cheaters don't win.
Yeah, I mean, maybe the ultimate cheat, in human life is really not doing the things, right, that you can do, right? Like you are basically cheating yourself out of the time and out of the potential. Everything else is kind of becoming blurry. Like, yeah, I mean, even in the area of physics, to kind of to your point, even at the Nobel Prize level kind of science, string theorists are absolutely not impressed with everybody else's theory, and they kind of are adults, and it's really kind of looking, like a very strong conflict, and then that kind of percolates to the life decisions, because then you have communities of kind of scientifically kind of like single-minded people who decide who gets funding, who receives tenure versus not, right? Who is let go, right? So those are usually very kind of there's this kind of scene in the Beautiful Mind movie in which there's this kind of like the supervisor or older person who is kind of looking at I think John Nash's kind of proposal, right? And he asks him, hey, do you realize, John, that everything that you wrote here goes against everything that we know in science, right? And he says, yeah. And then
I know.
And this person says, okay, continue, right? So yeah, it takes, I mean, who was more important? Almost feels like that this older scientist that had the power to actually shut him down was the more important person, because he allowed him to flourish, right, and develop his ideas. So yeah, I don't know. I mean, it's such a difficult problem.
Well, but I'm fantastically optimistic because, as I said, I think we've created our safe space. That's all. Like it's really, it's cheap. It's as good, at least to me, as having a PhD guy sitting here. You see what I mean?
Yeah.
Because I'm also in a realm, I mean, come on, it's physics, right? Like we figured this out 125, whatever, 100 years ago. Physics is fairly easy to model, except that it isn't, but whatever, you see what I mean? But it's not an unknown. And now we're in this brand new world. So I'm very optimistic about it. And I do think you're right. It's going to have mistakes because what else do we do, right? But let's say that it also says, hey, a person or a group of people can now probably, and I see it all the time, I'm seeing nothing but fantastic applications of AI in every realm whatsoever, right? Like how, and because real life is not a solvable problem, you know what I mean? Like there are real huge complexities in life that do take actual strategy, I think, to make progress within. But if you're spending all your time doing the paperwork, right, you know, and speaking of which, just as an analog, you and I both know this, but did you know how many jobs there were dealing with paper? Remember how much paper there was in the world, and that all paper had to be dealt with, it had to be filed, it had to see what I mean? Like I went Bank of America, files everywhere, and tons of jobs. I mean, really, when you think about it, fairly highly skilled jobs, because you didn't want
Yeah,
just anybody, right?
yeah,
Who could
yeah.
do
Japan
all,
is like that. Yes, Japan is
yeah.
like that. They actually don't want to go away from paper because they know about this issue about the jobs. You know, like, you know, what do we do with everybody? You know, there's a process. Okay, it's
Yeah.
paper based, but yeah, let's keep it, right? Maybe it's a good thing.
Well, 100%. So just because we love jumping on these bandwagons, but we literally did kind of eliminate all this, right? And now we have massive databases, which you're part of, right? Which are also formed by people who don't know anything about stuff. You see what I mean? Like that's why these databases are so much fun. Like how many, you know, how many real primary keys have you ever seen in your life, right? No, they're always just an int, right? Well, I have a problem with that because that's a bad model, right? Like why, sorry. Someday I'll do my thing about how bad data models, but let's just pretend they're all kind of bad, right? Because they're not understanding the subject. They're just getting it into a box, right? It's like a box. Here, that can go in that box. That can go in that box. Yay, we're done. Okay, check. You know, it's only for dependencies when you're then like, oh crap, I didn't check for nulls. Wait, what does null even mean in this context? That's the one I really like. You really needed to understand that when you built this model. Like, does null have meaning? Right? Do you not have a middle name? Well, certainly in your report, you're going to be like, most Americans do not have middle names. See what I mean? That's the problem with all this, right? You're going to start with these bad models, and then you're going to extrapolate them into having predictive powers. So throw your tea leaves where you may. But I think we're, you know, maybe better off. All right, Jack, I know I've exhausted you. I can tell.
Yeah, there's a lot. This is
It's
kind of,
fine.
this could go for
We
5 hours.
we have next week. Don't worry. I'll see if I can prove, you know, the curvature of space-time is not real by next week. All right, cheers.
Yeah, thank you, Mike.
Take care.